happens when a city locks down? How about a city that's told to lock down and kind of sort of locks down? There are lots of interesting digital artifacts left behind. Credit card transactions probably tell a very interesting story in aggregate, but of course those are private. But there are many wonderful public data sources. For example, the analytics data released by most community bike systems. In this episode, I interview Abdullah Kurkcu. We discuss some of his research into how cycling systems have changed pre- and post-pandemic. Here's the play-from-home portion of the show. What do you think happened? Did cycling go up because people had a bit more free time? Did cycling go down because no one was commuting? As with most things, the data will tell the true story.
My name is Abdullah Kurkcu. I'm the lead traffic modeler at Alltake.
And how did you first get interested in topics in data science?
Well, my area is transportation engineering, and I do have a big passion for transportation systems and traffic. And when it comes to traffic and transportation, you have to deal with data. I did my master's and my PhD in transportation engineering, which required me to learn a lot about data science, programming, forecasting, predicting, and so on.
And I'm curious, when it comes to transportation engineering, from my naive point of view, I live in a city, and although there's construction, the city's kind of basically done. They don't change the roads too much. What sorts of impact can transportation engineers have?
There are, of course, multiple ways to look at this. You're looking at a built environment when you think about cities, and transportation engineers will try to make transportation systems more efficient in cities like that. So if you have a built environment and you can't really build any other roads, what you try to do, you try to improve signal timing, or you try to introduce new modes of transportation to be able to lessen traffic congestion and also improve the efficiency of the existing system. So if there is like a new development, though, then you can actually build more roads into that new city or a new town. That will make transportation also better for everyone. So it all depends on the location you're looking at. But when you look at built cities, what we do is usually using the existing infrastructure to make it more efficient.
That makes a lot of sense. And, I live in Los Angeles, California, so pretty much every inch of real estate is taken up in some fashion. So those other modes of transportation are pretty interesting to me because you can add, more bicycles to the road or make it more amenable for bicycles to take to the road, and perhaps we'd have an overall more efficient system. And there's also trains. I guess anything else I'm missing that's interesting to you before we get all the way into bikes?
Of course, yeah. Well, again, talking about my passion for transportation, it all actually started when I was growing up. I grew up in Turkey, and then when I was a kid, I wanted to be a truck driver. So my passion goes way back. But the actual interest, it kind of started becoming an interest when I was studying at the college. And my commute was over 2 hours long. It was only 20 miles. And because of traffic congestion, I got stuck at a bus just watching slow cars passing each other. So thing happened there during my last year at college. They built an express bus lane that cut down the traffic travel time to 45 minutes. And when I saw that impact, I said, okay, there's always a better way to move people and goods from one location to the other. And that should be backed up by data, of course.
Absolutely. What sort of data sets are available?
So with the proliferation of mobile devices, now we have like big data sets and small data sets. The big data sets is pretty much the aggregation of all these transportation data services. Like Google Maps is one of them, right? Once you're traveling, you're checking the travel time. That data is actually crowdsourced from individual smart devices, which at the end becomes the travel time from point A to point B. But that's actually smart devices traversing our transportation system that generates data that can be used by us or any other traveler to inform their travel behavior decisions. So from simple counters, traditional traffic counters and speed detection sensors, all the way to smart devices and their mobility are used in transportation science.
So the presence of the smartphone is something that I guess I'm starting to take for granted, but I'm old enough to remember a time when none of us were carrying them. How has this, massive network of sensors changed your field?
Well, it actually helped a lot for understanding people's travel decisions and their travel plans. Nowadays, we do have a better idea of when people leave for work, what the peak hours are, how we can plan for it. And with the help of new emerging data sets in transportation, especially with the help of intelligent transportation systems, it is getting easier, but also harder to plan for future changes. We are definitely better informed to make decisions, but also now we have to deal with massive amounts of data to be able to analyze and draw some valid conclusions.
When it comes to bike share usage specifically, how did you first get interested in bike data?
So I'm a cyclist myself, and then when I was studying at New York University, I built a sensor which will detect the obstacles around me. I was trying to understand my safety because some of the cars were getting really close to me and it was making me anxious. It all started with that. I got into bicycle research. Then with the city bike being available in the city, I started looking at their data and how people use bicycles to go from point A to point B. And I got really interested in it. And then I was able to see the flows of people using bicycles. Even though I have a car now, I don't really like driving. So it all comes together that these are the things that made me interested in bicycle research.
Well, when you were in New York, I imagine you looked at their bicycle data API, which is a pretty sophisticated system in my experience that we've covered a couple times on the show to give you real-time access to that data. Do they have equivalent systems in the Colorado data set you assembled?
Well, unfortunately, no. New York is much better at it. In Colorado, they don't really have a system that allows us, like developers, to get access to their data sets. But what they have here, because they have many, many trails in Colorado, they do have continuous bike counters that anyone can go ahead and download the data. And some of them go way back to 2014-15, and it is still collecting data. And that's actually what I use for my research paper too.
Well, it's good that we've got a nice longitudinal data set like that, especially that it has a few years pre-pandemic, which will be interesting to analyze. So I guess longitudinally pretty nice. What about the width or the breadth of the data? How many data points, or can you summarize the data set in some way?
Yeah, so these continuous counters, I think they are infrared counters. So they look at the presence of any obstacles in front of them. So if you pass them, they count you as one. So this is a continuous counter. It works 24 hours a day for 7 days and for every day of the year, as long as they keep them on, they don't fail. So when I looked at the data, what I realized, it goes way back to 2015-14, but you have a count the number of bicyclists on those trails every day, and then you can get the hourly volumes as well as, if you want to aggregate it, you can get the daily or monthly, yearly traffic, I would say non-motorized traffic counts.
Well, sometimes when you have a data set like this that's kind of special, that is to say it was available and it's hard to go out and collect new data, especially from the past, sometimes you have a data set that you ask the best questions of, or other times there's a question you have that leads you to a data set. What took place in your investigation?
So I was looking, because like I said, I'm a cyclist myself too, and I was using one of those trails, and I moved here during pandemic, obviously. It was April 2020, and I realized some trails are more congested than the other. So this actually started with me trying to find trails that are less crowded so that I can cycle freely. But at the end, it became a research study that kind of showed the impact of COVID-19 on those trails and their traffic volumes.
So prior to looking into your study, I could have stated the hypothesis either way, that it would be up because people were, at home more, or maybe had the commute time they could now use for leisure activities. I could also tell it the opposite way and say it's going to be down because everyone's afraid and locked in. So of course, we've got to go to the data to get the answer. Can you talk about that process? What did you first start looking into?
I had the same idea too. I said, some trails are definitely more crowded and some are not. And this is a little bit like the maintenance and renewal theory. So what happens is that you have this car, it breaks down and you repair it and you go from the original state to another state that might be better or worse. I think that's what happened with COVID, especially for modes like bicycling. So we had that perfect original state, and then COVID, we can take that as some kind of breakdown. So what happened, it impacted the system. We introduced some preventative measures and we introduced some solutions as well, imperfect, but still solutions. Then the system went into a state that is different than the original state. Sometimes it's better, it's upgraded, sometimes it's worse. And that's exactly what I saw from the data set when I analyzed it.
If we look at some high-level metrics, maybe it's ridership per day or something like that, do you see an immediate regime change? And what was the before and after looking like?
For many of the locations, what we saw before COVID, that we had 2 peak hour periods. So that's kind of traditional for any transportation system because some people use bikes to go to work too. So you see that morning peak kind of start around 7 a.m. all the way to 9. And then you see the evening peak hour from 4 p.m. to 7 p.m. That was pre-COVID. But when COVID hit, especially in 2020, that peak, well, it was changed. So those peak hours were not there anymore. And we saw a more flat line starting from 9 a.m. all the way to 2 p.m. that people cycled at non-peak periods most of the time, and especially during their lunch breaks. Another interesting thing that we saw, so those peaks were like flattened out, but those peaks were returned on weekends. On weekends, we saw more people cycling in the morning and in the evening peak hours. And I think the reason being because they work from home and they want to get out on the weekends and probably use those really beautiful trails during the morning peak hours and evening peak hours.
And so in the system, I think there's multiple stations. Can you talk a little bit about how much coverage there is that you're able to look at?
Yeah, sure. So there are over 10 continuous count locations that we analyzed. Unfortunately, there weren't any in Denver downtown, but we used counties that are nearby. So we looked at the greater Denver area. We used over 5 stations and over 3 years of data to analyze the bicycling behavior of commuters mostly.
And do you have any additional parameters you can apply that distinguish these stations from one another?
Yeah, what we did was for each location, we looked at the sociodemographic data. We created a buffer around the station to be able to understand that capture area. So we were looking at potential cyclists within the area, and we used the available sociodemographic data to understand what would be the underlying reason why people cycle.
Today's data lives in the cloud, so your business needs a cloud-native, next-generation solution for intelligent, accessible data analytics. Astrato is a modern BI solution for modern BI teams. Your organization's data already lives in the cloud, which means you can access the single source of truth. Astrato accesses your data where it already lives with a live query approach, so there's no need for data movement, ever. You maintain the agility, speed, and elasticity that modern cloud data warehouses deliver. Astrato's gallery of examples will give you a quick impression of the power Astrato can give your team. The sales workbook example gives me a good indication of the quality of dashboard I can create for my collaborators. And the Tour de France workshop shows off a few other features on competitive cycling data that I could see being really inspiring on implementation for when I have a demanding executive that needs to really slice and dice the data in a lot of custom ways. When I first started exploring Astrato, I connected a Google Sheet of one of my data sets just so I could kick the tires. After that, integrating with Snowflake as a backend was super easy. You'll find that integration to be pretty painless and definitely worth your time checking out if you're a Snowflake user. With Astrato, you can bring complex data to life with no coding skills necessary. To learn more, visit astrato.io/dataskeptic. Astrato is ASTRATO. Astrato.io/dataskeptic. Thanks to our sponsor BB Edit from Bare Bones Software. If you're a Mac user, and you have any need whatsoever for a text editor, which, let's face it, that's got to be all of us, you have got to check out BBEdit. BBEdit 14 provides Mac users the most powerful, professional-grade text editor around. It's known as capable and rock solid, and can process files that are large enough to bring other editors to their knees. This tool's been beloved for over 25 years, and I can understand why. If I'm just typing up some simple hello world, I guess any text editor will do. But when I really get into the weeds and need to do some data processing, maybe I've got a big messy file, I need to find all the non-ASCII characters and remove them, BBEdit's there for me. It has best-of-breed multi-file search and replace and great scripting support for text transformations. There's a whole menu of text transformations that you'll find handy. If you're a serious data scientist or software engineer, you're going to bump into situations where you need a powerful text editor. So download and try BBEdit today. You can get it at www.barebones.com. See how much your productivity can increase. barebones.com and download BBEdit. And that socioeconomic data, is that census data, or do you know that on a per-writer basis?
We use the available census data for the most recent year. Our data included things like age, income, gender, and total population for the area.
So these are definitely interesting factors to look at, and I like your approach that you should find, neighboring data to the actual station and assume that it's people who are, walking distance or some radius from it are almost certainly the users of that. Although the census doesn't necessarily perfectly align with the ridership as well, right? It could be that, there's an abundance of older people who might not bike as much and a set of younger people who are very cyclist enthusiasts. Do you have to worry about some sort of bias in the analysis in this regard?
Yeah, there's actually bias because that bias is introduced by the lack of data, and this is a general problem for any kind of bicycle research. Even though we have a lot of data for vehicular traffic, most of the time the research is a little ignored when it comes to non-motorized modes because they're not popular. So we don't really know the exact preference of these people unless we go there and survey them. Even that might introduce some bias because most people don't want to answer those questions voluntarily. So that's the biggest problem that bicycle researchers face most of the time. Once you survey people, the people who answer those questions are either avid cyclists or people just do not have any idea of cycling. So it is really hard to get that representative sample of cyclists to be able to draw the right conclusions. But in our research, at least our model tried to include predictors, and that the model included something that will handle collinearity a little bit between those different parameters, because when you think about age, income, and population, they're somewhat correlated with each other.
Well, I definitely want to explore that a little further and the regression you guys did, but I'm curious first, at face value, are there any obvious statistics? Like gender, there's only two options, I think, in the census, male and female. Has there been a significant change there, or by age, or does anything stand out when you look at a univariate distribution?
Yeah, well, gender definitely was interesting to see because we've seen a big jump in female cyclists. Even though this is not part of my research, I was also part of another research study that asked those questions that, if you cycle, et cetera, we asked about their, mode choices and travel behaviors. We've seen that there's a big jump in the number of female cyclists. And this can be backed up by other researches, such as, I think, MBDA, National Bicycle Dealers Association, recently shared a report showing that 33.4% of women who started cycling and 22% returned in the last 2 years. So we definitely see that jump of female cyclists. So I think that's one benefit of COVID.
So we have this data collection process you described, and then we're able to attach features to each of those stations through the process you talked about. What happens next? Is there an objective variable we'd like to predict?
So the objective variable was to be able to predict if there's going to be an increase or a decrease because of COVID-19. But while doing that, we realized, okay, we can't just have only two time spans pre-COVID and after COVID. Because the behavior, once you aggregate those different time lengths, different time periods, you're missing some of the changes in between. That's why we created different transition periods to be able to understand that shift better. So when I look at the research on the impact of COVID on transportation systems research, a lot of people will only look at pre and after COVID, even though the actual behavior transforms over the course of the whole COVID-19. So especially for vehicular traffic too, I analyzed traffic data for Denver from all the way from 2019 to 2021. What I've seen is that 2019, taking it as the original state, in 2020, there was a big reduction in traffic volumes. And in 2021, now it's going back to the original state. It's not there yet, but you also see a different distribution of traffic during peak hours. So it is better if you define those time periods in a way that will give you more answers by looking at historical data.
That's very appealing to me from an intuitive point of view. It would be very wrong to say it's, so binary that the day COVID started, which first of all, what's the day, that people immediately switch to their new behavior. For sure there's transition periods. Do you do those by calendar year or where do you draw the lines?
So we took pretty much a little random, but we took 3-month periods once we look at the transition, but that was the availability of the data back then. Now you can actually look at, if you want, you can still have those 3-month slices of data, or you can have multiple years, multiple months. The analysis will probably produce different results based on the segmentation of your time period. So we looked at the number of cases once we decide that, okay, this is our transition period from pre-pandemic to pandemic, pandemic to transition adaptation period, and then transition to normalization, somewhat of a normal levels. But we only draw those lines by looking at the volume data, just comparing historical volumes with the newly collected volumes.
And do you do any additional data processing or feature engineering with the census information before you run a regression?
For census information, yes, we did. The problem with census is that it is provided at a more aggregate level, and we were looking only at the buffer around our station. So by just looking at the number of houses around the station, we sliced the population data that was provided for a bigger area. So there was some kind of post-processing of census data to be able to get a better estimate of population given our buffered area.
Makes sense. And then let's talk a little bit about the regression itself. You're using a technique called PLSR, which I believe is partial least squares regression. A known technique, but not necessarily the go-to for a lot of data scientists who like the flashy stuff like random forest and XGBoost. Why was this the right algorithm to explore?
I kind of mentioned that a little bit. So PLS regression is actually a technique that reduces predictors to a smaller set of uncorrelated components and then performs least squares regression on those components rather than the original data, because the original data for us, they were highly collinear, and when you have more predictors than observations, that's usually the case. The ordinary regression methods either produces coefficients with high standard errors or they usually fail completely. I know that new methods like random forest or XGBoost are used in machine learning a lot, but what we wanted to do, because we really wanted to understand the importance of these variables as well, regression was something that was a low-hanging fruit for us. But then the regular regression we couldn't use because of collinearity. We decided to use partial least squares regression because the main objective was not to actually predict accurately what's happening, rather understanding the importance of each of these factors, such as age, income, and population.
So you were looking to predict whether or not usage would go up or down. Prior to getting into the data itself, were there any obvious trends? Like, was it the majority of stations were up, but there were just a few outliers that were down, like a class imbalance and a fraud detection problem? Or was there really no intuitive way to make an intelligent guess prior to the analysis?
I think an educated guess would be, from my experience, I can say if the education level is higher, more people will cycle. That was my intuitive prediction, and that turned out to be right. Actually, when the average education level is high, more people cycle. And then the same thing with income. So if you look at an area that the average income is higher, more people will cycle. And then the surprising factor for me was it was the population. When you see a more crowded area, less people cycle in that area.
Interesting. And does the regression itself pick up on some of these factors?
They actually did. It, again, based on the period you're looking at, but from pandemic to transition, you see what my predictions were valid. Average income and average education kind of improved the number of cyclists. Average age, it decreases the number of people who cycle in that area. And then the total population, same effect. If you see more people, less people cycle in that area. But that shift changes based on the period you're looking at. So in the introduction of COVID, everything was lower except education level was positively correlated with the number of cyclists on the road. But then transition, I just summarized that one. And the last segment that we looked at, it was a little random. It was highly correlated with the location.
And do you see that as being a state of transition, that this is still a dynamic system evolving, or is that just the new steady state?
In my opinion, definitely it's a dynamic state. We don't know where it's going, and it is really hard to predict. And it is highly depending on the input data that you use to predict these levels.
Well, my interpretation, and this is highly colored by my personal experience, I like bike riding, so if ridership is up, that seems like a positive for the citizens. I guess maybe if you've run into trouble and you had to get rid of your car for financial reasons and switch to a bike, it's not good for you, but I guess that's the reason for my question. Can we walk away with any general analysis or commentary that tells us about the people who could have access to the system and choose or don't choose to use it?
Yeah, this is an opportunity for many local governments to invest more in cycling, which is proved to be one of the best methods to make shorter trips, especially. And then it's healthier, obviously, on your own, cycling this, using a trail if it's available to you. And hopefully in the future, governments will invest more on those trails so that people can use non-motorized modes to travel from one location to the other. And then what I see in bigger cities, maybe they cannot build more trails. What happened was closing roads to vehicular traffic to make cities more walkable or cyclable. And I really like that shift in transportation. And we have this theory, it's called triple convergence law or triple convergence theory, that says if you build more roads, more people will use it. So I think this applies to cycling and walking as well. If you build more sidewalks, if you build more bike lanes and trails, more people will use it.
And is there anything specific to the stations you studied that the operators of that system maybe could have as a good takeaway? Are there any learnings or insights that could help them improve their operations in some way?
So I think because we used age, population, education, and income, I think it gives you an idea of equity in our transportation system. I think this is a big conclusion that this research had. So you can see some of the variables and like some of the underlying reasons why people cycle. It's either with the availability of those transportation infrastructure or their like income or their age level. So once they want to invest in more trails or bike or pedestrian trails, they can use some of this information that are readily available to them to make those decisions and try to balance that transportation equity within the state or within the city or even at a local town or municipality.
So the paper has some great conclusions, and it could be sort of the end of this line of inquiry, but I could see as well where there's value in doing this longitudinally and maybe studying it year over year for a while or things like that. Does this fit into your research plans and work for the future?
I actually help local governments and state governments to come up with bike and ped plans. That's part of my job. And I actually use these like station data or available bike sharing data to be able to understand where we can build trails next. And we do help states like South Dakota or North Dakota, Colorado. Colorado is more built, but when you look at South Dakota, you have a lot of opportunities to connect trails And a decision usually is informed by, we do use data-driven decision making once we try to pick a location that will be used by local citizens.
Well, very cool. It's actually exciting work. Is there anywhere online people can follow what you do or follow you personally?
I do have my Medium blog that people can follow. It's pretty much my name and my last name. And then they can take a look at my Scholar page if they're interested in those research studies.
We'll have links to both of those in the show notes. Abdullah, thank you so much for taking the time to come on Data Skeptic.
Well, thank you very much for the opportunity. This was fun.
That concludes another installment of Data Skeptic Physically Distributed. Thanks to our sponsors, Astrato and BB Edit by Barebones Software. Myself, Claudia Armbruster, as associate producer, Vanessa Bly, guest coordinator, show notes written by David Abembe, and our host, Kyle Polich.